As nobody has joined, we'll wait for 5 minutes before starting. Okay. Welcome, P. Hori Babu. Good evening. So we'll wait for 5 minutes for some other people to join. Then we'll start. Okay, so I believe we can start. I'll share my screen and with your permission, I'll start the recording. Okay, so hopefully, I believe my screen is visible and I am loud and clear. Okay, so my name is Shudhar Sadhavan. I'm a teaching assistant and a Prime Minister Research Fellow as a PhD student of IIT Bombay. I'm your facilitator for the live interactive session of NPTEL course code AR18, instructed by Dr. Devapratim Pandit, who is a professor of IIT Kharagpur at the Department of Architecture and Regional Planning. The course title is Urban Utilities Planning, Water Supply, Sanitation and Drainage. Today is Sunday, October 6th, and we have covered almost all the sessions of the previous months up to this September. So we have covered 10 sessions till now. Only two sessions are left. This one is the 11th session, and after this, only one session will be left. So it is expected that whatever you are having doubts regarding the entire course, it is expected that you should clear all of them in these two sessions, because only one more session will be left after this before your final examinations if you have registered for it. Okay. So now, last class actually we have showed you this quotation of a famous person who is a stand-up comedian of USA. His name is George Carlin. He says, "Never underestimate the power of stupid people in a large group." Why we said that? We actually said the quotation for the following, for to clarify one statement which was given by Hooghly parliamentary constituency of the state of West Bengal. Uh, so there it has the MP, which means member of parliament. She made a statement on the quantity of liquid water, but due to the ignorance of the people, they actually they didn't have any idea about the liquid property also should have mass, right? So liquid on not only liquid has volume, but liquid has a mass. Even mass is a more fundamental property of any state of matter, irrespective of its state, be it a solid or be it a fluid. So any quantity of matter can be measured in terms of mass or volume. Uh, so not only the liters, not only the quantity of liquid is measured in liters, but also it can be measured in terms of mass. That was discussed in the last class. This is a very basic fundamental concept actually, but people have forgotten. That's why they mocked that person. Though whatever statements he made, it was perfectly scientifically correct. So the volumetric units may be liter, cc or ml, but mass units are can be expressed in terms of tons, kgs, or grams or quintals. So quintal is a perfectly scientifically correct unit to measure the mass of any liquid like water, which is our case. And also we can say that the density and the volume of fluid, it changes with respect to the temperature and pressure, but the mass remains constant irrespective of temperature and pressure. So if you are though the major market practice is to express the quantity in volumes, because the manufacturing company who manufactures the bottles, their sizes remains constant. So that's why it is very convenient for them to express the quantity in liters. But that doesn't mean that it cannot be measured in terms of mass, like the unit quintal. And also we clarified one thing, the difference between the volumetric flow rates, which is nothing but qmec, and the static quantities like volume or mass. So these two are the volumetric flow rate or mass flow rate, and the volume or mass. These two are rates, and the static properties are different properties. You can express the quantity in any one of them as per your convenience, as per your engineering application. Okay. So after this slide, we actually clarified the concept on the density of liquid water, which is maximum at 4 degrees centigrade at atmospheric pressure. But as we go beyond this temperature, the density decreases, but not below 0.95 gram per cc or kg per liters. Both are same unit. So even if the temperature is around room temperature, like 25 or in the range of 25 to 35 degrees centigrade under atmospheric pressure, then we can confidently say that the density will remain approximately 1 kg per liter. So 1 kg mass of water has a volume of 1 liter at 1 atmospheric pressure, whatever the temperature be, because water remains in liquid condition from 0 to 100 degrees centigrade at atmospheric pressure, and within this range of temperature, water density remains approximately equals to 1. It doesn't go below 0.95 gram per cc. So we can, for engineering approximation, we can safely assume it to be 1. Now, 1 quintal of water hence is equivalent to 100 liters of water at atmospheric pressure, that we have proved. And hence the statement that was made by that person, it was 100% scientifically correct, that we have told. Okay. So one problem, actually two problems was discussed in the previous class based on the Manning's formula. Now, Manning's formula requires a terminology which is written as M or R suffix H, which is nothing but called as the hydraulic radius. And it is a matter of pride for a teacher like me that students are very attentive in the class. And in the last class, one of the students identified one major mistakes that was there in the slide for the calculation of hydraulic radius. So two problems was there. One problem was perfectly fine, but the other problem, it had got certain problems in terms of calculation of hydraulic radius, which is a terminology in Manning's formula. So we will rediscuss that problem with the correct solution in today's class. So today's class will start with this problem, which was discussed in the last class, but with certain mistakes. So the problem was like this. So a sewer is laid at the rate 1 by 400 slope. The diameter of this sewer is 160 centimeter. Now, assuming n, which is a coefficient in the Manning's formula, it was given as 0.015, and it was assumed that the sewer is running half full. Now, considering the above sewer data, we had to answer the following questions. The first question was, what is the velocity of the flow in the sewer in terms of meter per second? Okay. So the data given is diameter is 160 centimeter, that means 1.6 meter, which implies radius is zero point 0.8 meter, half of that, half of the diameter, and slope I was given as 1 by 400. Manning's formula is given as V equals to m to the power 2 by 3 into root over of I whole divided by capital N. Now capital N's value is given as 0.015, which we have put in that formula. Next, the small m is nothing but the hydraulic radius, which is defined as the weighted area by weighted perimeter. So for sewer running one half full, we made this mistake that we assumed the entire perimeter to measure the value of weighted perimeter. The value of weighted area was correct in our previous problem. So it is nothing but pi r square. That means pi d squared by 4 divided by 2, because the CUR pipe is half full. So we are taking half of the entire cross-sectional area as the weighted area. It was correct, but in terms of calculating weighted perimeter, there was certain problem. So which one student correctly identified. So when you are calculating the weighted perimeter, you should not consider the perimeter which is not in touch with the pipe. So we considered the diameter as a part of the weighted perimeter, but it is not to be considered because uh, the diameter, that means the surface, top surface of the uh, weighted area, does not touch the sewer pipes wall, internal wall. Only the half of the circular perimeter only touches. Half of the circular perimeter is the perimeter where the fluid, that means the water, touches the inner wall of the pipe. But here the water does not touches the inner wall, so we don't have to consider this. We have to consider only this half portion, which is nothing but 2 pi r by 2. That means pi r. Pi r means pi d by 2. So weighted area means pi d squared by 4. Weighted perimeter means pi d by 2. Now the rest of the problem uh, goes similar to as we discussed in our last class. So this we just divided the entire the both the denominator and numerator with the term d by 8. So if you divide the numerator with d by 8, it gives us pi d, and if we divide this denominator with d by 8, it gives us the term pi into 8 by 2. Okay, which is nothing but equals to pi d divided by 4 pi. So 8 pi by 2 gives us 4 pi. Now this pi gets cancelled out, which gives us d by 4, which is nothing but our hydraulic radius. Hydraulic radius is 1/4 of the diameter, or normal. It is half of the normal radius when the sewer is half full. Now, which is again nothing but equals to r by 2, half of the radius, and radius is 0.8 meter. So hydraulic radius becomes 0.4 meter for half full sewer pipe. Now we obtain the answer by substituting the values of n, m, and I. N we have already substituted. I is given as 1 by 400. Now the value of m we have calculated to be 0.4, which we substitute in the Manning's formula to get the solution. So V becomes equals to, V is nothing but the velocity, which is nothing but equals to m, that means 0.4 to the power 2 by 3 into root under of uh, I, which is 1 by 400, that means 0.0025 whole divided by 0.015. After simplification, it gives us 1.8 meter per second, which is the correct answer. Now, based on this velocity, next we have to determine the discharge flowing through the sewer in meter cube per second unit. Meter cube per second means cubic unit. Okay, 1 cubic approximately equals to 35.315 cubic. That means cubic feet per second. Okay. Now, the data that was estimated earlier was small r radius is zero point 0.8 meter. Velocity was determined to be 1.81 meter per second from the Manning's formula. Now, based on that, we get the solutions where they have asked the volumetric rate of discharge. If they asked about the mass rate of discharge, then we could get the mass values like gram per second or kg per second or quintal per second or tons per second, whichever they have asked. But they have not asked here. They only asked here the volumetric rate of discharge. So that's why we are calculating the volumetric rate of discharge. Okay. So now Q is the volumetric discharge, which is nothing but the weighted area into velocity. Weighted area means the portion of the area through which the fluid is flowing. So this one is the weighted area in our case, half of the entire area, into the velocity with which the fluid is flowing perpendicular to the plane of paper. So weighted area is nothing but the total area cross sectional divided by 2, because it is half full into velocity v that we just have calculated. So capital A means pi r square divided by 2 into v. Now pi into r square means 0.8 square means 0.64 divided by 2. This many meter square into velocity means 1.81 meter per second. After simplification, it will give you meter cube per second. That means cubic. So which is nothing but equals to approximately 1.82 meter cube per second or cubic, which is the correct answer of the problem that we just discussed in our last class. Okay, two problems we discussed. The first problem, there was some problem because of the calculation of hydraulic radius, but the second problem was fine. Okay, so next today we'll start with a MCQ. Sorry, MSQ, multiple select question. So more than one options may or may not be correct. Okay, so the potential of the maximum retention of rainfall through infiltration is independent of characteristics of soil vegetation and land usage, antecedent soil moisture conditions, quantity of rainfall, duration of rainfall. These are the four options. So one or more option may be correct. You have to think and give the correct options. Type it in the chat box. I'll wait for 1 minute. Okay. So yeah, try this out. Okay, so not able to answer. Okay, we'll move on to the solution. Now the answers are option R and option S. So quantity and rainfall and duration of rainfall, uh, both actually does not affect the maximum retention of rainfall through infiltration. The retention depends on the characteristics of soil vegetation, land usage, and antecedent soil moisture conditions. The first two options are the factors which affect the maximum retention of rainfall through infiltration. Okay, P and Q are the answers for they affect the it is so the question mentions maximum retention of rainfall through infiltration is independent of. That means most probably you thought that is dependent on. You thought like that way. So maximum retention of rainfall through infiltration is dependent on the option P and Q. Okay, but is independent of option R and S. So R and S are the two factors which don't affect the parameter, that is the maximum retention, but the P and Q are the parameters which affect the maximum retention. Okay, hope it is clear. Most probably you didn't understand the term independent of, that's why you get this answer, right? Or whether any more doubt is there. Whether any conceptual doubt is there, then we can discuss. Okay. And then please tell if you have any conceptual doubt on this. Otherwise, if just a matter of reading the question, then it's okay. We will proceed. I'll take it that no conceptual doubt is there. So we'll move on to our next MCQ, multiple choice question. So one option will be correct. When air test is used to test sewer lines. Option A is to test smaller diameter pipes, those allow smooth air movements. Option B is used for testing of large diameter pipes when water is unavailable. Option C is air test is used in the cases where air cannot be used in order to test sewer lines. And option D is air test is used in the regions with heavy backfilling. So these are four application areas of air test. Three application areas are wrong. One application area is correct. So whichever is correct, you have to identify it and type in the chat box. Okay, I'll again wait for 1 minute. Okay, not able to answer. Okay, you have given the A as the answer. Okay, great. We'll see the correct answer. So the correct answer is option B, not A. Air test is used for testing of large diameter pipes when water is unavailable. Large diameter pipes are the sewer lines. It is not used to test small diameter pipes that allow smooth air movements. So if the air is in smooth movement, you cannot use air test to use, to determine the usability of sewer lines. Okay. So option A is not correct. Option B is correct. It is just a memory-based question. You have to just to remember the answer. If you remember it, then it's correct. If you don't remember, then you have to guess. That's all. Okay. So now next MSQ. It is a multiple select question. Again, more than one option may or may not be correct. Which one or which of the following statements is or are correct regarding the time area method for runoff estimations? Option A is time area method transforms hydrographs from storm into runoffs. It cannot account for the temporal variations in rainfall intensities. Option C is time area method is based on the concepts of time area histograms, and option D is the time area method is an extension of the rational method. Okay, again a memory based question, but more than one options may or may not be correct. You have to think and type the correct options in the chat box. We'll wait for a couple of minutes in this time. A, C, D, you are telling as the answer. Okay, so we'll see. The correct answer are A, C, D. Yes, definitely. You are correct only. Option A and C and D are correct options. And option B also you have to remember that the time area method can account for the temporal variations in rainfall intensities. So that's why option B was incorrect. Okay, all the properties of the time area method you can get through these options. Now next is MCQ. One option correct. Sewer cleanings are undertaken on a scheduled basis in order to option A reduce blockages per unit length of the sewer. Option B is to remove deposits. Option C is minimize odors. Option D is all of the above. Sewer cleanings are undertaken on a scheduled basis to do what? All of the above or any one of the first three that you have to determine. I'll wait for 1 minute. Okay, you have given the answer as D. We'll see. One another option was there, none of the above. Sorry about that. Okay. So the correct answer is option D. Yes, you have answered it correctly. All of the above are the objectives of sewer cleanings on a scheduled basis. Now, next MCQ or multiple choice question is, what is SCSCN method used for? Option A to trap grasses, option B to estimate the size of the sewers, option C is to estimate the surface runoff volumes for long durations, high intensity rainfalls, and option D is to estimate the limiting velocity. Let me check whether any other option is there. Oh, okay. Another option is there is to design a sewerage network. So only one option will be correct also in this case regarding SCSCN method. Okay, I'll wait for 1 minute. So what is this SCSCN method is basically soil conservation services. The term SCS means soil conservation services. Okay. Okay, you have given option C as the answer. So look. So yeah, as I told earlier, SCS CN means Soil Conservation Service curve number. It was a method deployed by the US SCS department in order to estimate the runoff volumes under the American conditions. Okay, so this method estimates runoff for longer durations, high intensity rainfalls over smaller drainage basins. So option C is the correct answer, as you have correctly told. Now next, there is a table. You have to match the following types of sewer cleaning equipments with their system characteristics. So sewer cleanings equipments are given in the left hand column. So there are four types of equipments, uh, namely Manila lobe and cloth bulb sectional sewer rods, sewer cleaning bucket machine, dredge. Third option is flashbacks, sewer scooters, and the fourth option is suction units, velocity cleaners. Now there are three types of cleaning system characteristics are given in the right hand column, namely hydraulic systems, manual systems, and mechanical systems. Now you can see there are four types of equipments, but three types of cleaning system characteristics. So basically, one cleaning system characteristics will be repeated for two types of equipments. So it may be you can write keep the this left hand order as same PQRS and tell me the right hand order. It may be like this way. So 1 1 2 3. It may be like this way, or 1 2 2 3, or it may be 1 2 3 3. It may be something like that. So you have to state one of the cleaning system characteristic type. You have to code that twice in order to accommodate for all the four types of equipments. So in this way, you can tell me the correct answer, correct chronological order. You can tell me from the right hand column. I will again wait for a couple of minutes. Okay, you have given answer. Let me check. So you have given one with Q. Okay, 3PR 2S. Okay, so it is basically one with Q, 3PR. Okay, so 3 1 3 2. Yes, so this is your answer. 3 1 3 2. Okay, right? We'll see. So it's basically not 3 1 3 2. It is 2 3 1 1. So we'll clarify it. So all of the options R and S are hydraulic systems. So flashbacks, sewer scooters, suction units, and velocity cleaners. These all are hydraulic systems. Okay. Sewer cleaning, bucket machine, and dredge. These option Q are mechanical systems. And manila rope, cloth ball, sectional sewer rods. These three are option 2, that is manual systems. So this machine, cleaning buckets, these things are your mechanical systems. If you just see the names, it will be clear. The flashbacks, flashing, or the where you have to use water jet velocity in order to clean something. So these naturally comes under hydraulic systems. And the leftover is your manual systems, where ropes, cloth balls, this cannot be mechanical, right? This will be manual. One have to use by hand. The sewer rods and all, rod means one have to just insert a rod and push something in order to clean something. So that is the thing. So P goes with 2, Q goes with 3, and R and S both are 1. Okay. What happened? Okay. So we'll move on to what? Next problem. Where you have to determine the minimum required diameter of a circular sewer, making use of the following data and assuming maximum discharge as 1.5 times of average one. Now the data is given as area to be served is 130 hectares, population of the locality is given as 60,000, maximum permissible velocity is given as 3 meter per second, time of entry is given as 5 minutes, time for flow is given as 20 minutes, rate of water supply is given as 230 LPC, that is liters per day per capita. Okay. Now the last assumption is impermeability factor is given as 0.45. Based on the data, you have to calculate. Okay. This is not a very easy problem. You have to remember the formula and all. I'll wait for 2 minutes for you to think in certain direction. Even if you are not able to solve this problem, it's okay. But at least I'll give you some time to think. After that, when you will solve, so that you can check uh, through the solution procedure and your thinking also, whether you have thought it in the correct direction or not. That's why. So we'll wait for a couple of minutes before proceeding with the solution. Okay, so we can proceed with the solution, I guess. So before proceeding with the detailed solution, we have to remember one thing, that is the rational formula. Rational formula is given as Q equals to CIA by 360. So this formula you have to remember. But even if you just conceptually, you can also remember this formula. How? So here you can see that we have to ultimately calculate the required diameter. So in order to get the diameter, we have to get the volumetric flow rate, right? Now, after that, we will divide the volumetric flow rate with the velocity, and after doing that, what we will do, we will get the surface area. As it is your circular sewer pipe, if we know the surface area, we can easily determine the diameter, because area is a function of diameter. The formula is pi d squared by 4. Easy enough. So that's why we are remembering the rational formula, because rational formula here, Q or volumetric discharge flow rate in Q sec or Q meg, whatever it is given. So what is basically this CIA thing? That we will see, the C is one factor. It is given as the impermeability factor 0.45. The I is your precipitation rate, and A is the area. Okay. So while solving this problem, we'll see why the 360 factor came into the picture. So first you have to remember this formula. Keeping this formula in mind, we'll proceed. So first, the explanation goes like this way. Quantity of water supply is given as 60,000 into 230. So what is this 230? 230 is nothing but your liters per day per capita. So to convert it into liters, we are first multiplying it with 60,000, which is the population, which gives you liters per day. Then again we will multiply with 1 day, which will give you the liters. Okay. So 60,000 into 230 liters per capita. That means this many liters per day. Now, if you want to convert it into liters per second, you have to divide it with 3600 seconds in 24 hours. That means 1 day, which gives you, after simplification, approximately 160 liters per second. Next, assuming the maximum discharge as 1.5 times of the average one, so the quantity of water supply that we got here, it is the average water supply. Now you have to get the maximum discharge by multiplying this 160 with 1.5. We get approximately 240 liters per second, or which is approximately 0.24 cubic or cubic meter per second. Hope it is clear till this point. Now, the concentration time is nothing but the summation of time of entry and time of flow. Now, time of entry is given in the question as 5 minutes, and time of flow in the question given as 20 minutes. So, after adding them up, we get the concentration time as 25 minutes. Now, concentration time is nothing but the duration of the storm, which is symbolized as small t minutes. So, t equals to 25 that we got from the concentration time. Next, using the formula for intensity of rainfall, which is nothing but the small I, and intensity of rainfall is given in millimeters per hour unit. I is given as 25.4 A divided by T plus B. This is again another formula which you have to remember. So that's why so many memory based things in this problem. So what are these A and B? A and B are coefficients. This 25.4a divided by small t we have calculated from the concentration time to be 25 plus b. A is 30 and B is 10 when the range of small t is 5 to 20 minutes. Now, if the range of t is 20 to 100 minutes, which is our case, 25 lies in between 20 and 100 minutes. So that's why the formula for within the formula for intensity, the value of A and B will be 40 and 20. After putting those values of A and B, we get the value of intensity as 25.4 into 40 divided by 25 plus 20. That means 45. So 40 by 45 means how much? 45 by 45 means your 8 by 9. So if we multiply this factor 25.4 with the factor 8 by 9, we will get the intensity as 22.6 millimeter per hour. Now this I value we have to put here. Okay. Now why this factor 360 came into the picture? So you can see here the value is given in millimeters per hour. Here the value is liters per second. So there some unit conversion is taking place, right? To keep a parity between these two. So that's why basically this factor 360 came into the picture. This is just coming because of the unit conversion. Now next, we'll start with this formula Q equals to CIA by 360. C value is the factor given in the question as 0.45. I value we just calculated to be 22.6 into area is 130 divided by 360. Now area, you can see it was given in the question. Area to be served 130 hectares. So that's why area was given in the questions. Impermeability factor was given, C was given as 0.45. So from here we just calculated those data. After simplification, Q value came out to be 3.7 meter cube per second. Therefore, combined discharge is equals to, so you can see I value is in millimeter per hour. So if you convert this per hour into per second, you have to divide it with 3600. But again, this millimeter thing, you have to convert it into meters, and area is given 130 hectares. So hectare again you have to convert into meters. So after this conversion takes place, there will be 10 in the numerator. So in the denominator there will be 3600, in numerator there will be 10. So 3600 by 10 gives you 360. This is how the value of 360 came into the picture. Now to keep the parity between these two units, this was the data we calculated earlier, and this is our current data that we have calculated. So combined discharge is nothing but the summation of the summation of the discharge that is coming from this rainfall thing and the water supply. Okay, which is the 1.5 times of the average one. So this value plus this value is giving us 3.91 meter cube per second, approximately 4 meter cube, 4 cubic, cubic. Okay. Now Q volumetric discharge rate, as I told earlier, is nothing but the multiplication of area into velocity. Hence, area will be Q, that is your volumetric flow rate divided by velocity, equals to 3.97 by 3 equals to 1.303 meters squared. This is your area. Now again, if you look earlier, you will see that the maximum permissible velocity is given as 3 meter per second. Number 3, point number C. So that's why we got the V value to be 3. So 3.91 by 3 equals to 1.303 meters squared. This is the area. Therefore, the diameter of this sewer D will be equals to root under of 4a by pi. This many meter. How we are getting that? So area is nothing but pi d squared by 4. So this 4 came into numerator of the other side and we divided it with pi. So d squared equals to 4a by pi. Now d equals to root under 4a by pi meter. Hopefully you are understanding this formula. So which is nothing but equals to a value we just put here. Then 4 into this one, 1.3, that means 5.2. So 5.2 by pi and to the power half. That means root under square root of the entire thing gives you 1.3 meter approximately. So the solution will be approximately 3 meter in rounded figure, which is nothing but the minimum diameter required for this sewer. Hopefully this is clear to you. The problem, any question, then you can ask. Otherwise, we will proceed to the next problem. Okay, just uh, go through this once again, then we will proceed. Okay, so our next MSQ multiple select question, where more than one option may or may not be correct, is sewer trench width directly depends on option A, sewer line diameter, its bedding and or shoring types, 1 or 2 stage. Option B is working space required inside the trench and the type of ground and soil below the surface. Option C is adjoining services and or nearby structures. Option D is length and or slope of the sewer. So these are the 4 options upon which the sewer trench width directly depends. Again, it's a memory based question where more than one option may or may not be correct. So try this one out. I'll wait for 1 minute. Okay. We have given this answer as A and D. Oh, sorry, A and B. Okay. You see. So the correct answers are width of the trench depends on sewer line diameter and its bedding, type of shoring, single stage or double stage, working space required inside the trench, type of soil, and ground below the surface, adjoining services and nearby structure. You have given as A and B as the answers. C is also another answer. Yes, D is not an answer. Length and or slope of the sewer is not a factor on which the trench width depends. Okay. width of the trench does not depend on the length and or slope of the sewer, but it does depend on adjoining services or nearby structures. So C is also another correct option, but A and B you have identified that correctly. Okay. Thank you for your participation. Now we'll move on to our next MCQ. Multiple choice question. One option will be correct. What is meant by return of a storm event? Option A, average recurrence interval between storm events is greater than equals to a specified value. Option B, duration of a storm. Option C, time taken by storm water in order to return to the rivers or lakes. Option D is time required for the rain falling on the most remote points of a catchment in order to flow across the ground surfaces along the drains. So, return of a storm event, there are four options. All of the four options are different timings, right? So, option B is the duration of the storm. Option C is the times taken for storm water in order to return to the rivers or lakes. Option D is again time required for the rain falling on most of the remote points of a catchment in order to flow across the ground surfaces along the drains. And first option is again it is also another time, but it is an interval, average recurrence interval between storm events which is greater than equals to a specific value. Which one is the correct definition of the return of a storm event? Which uh, type of time is the correct option? You are telling us A as the correct option. Okay, we'll see. Yes, so option A is correct option. You have identified it correctly. Now we'll move on to our next MSQ or multiple select question. More than one option may or may not be correct again. You have to choose the incorrect statements on sewer layouts and or sewer installations. Option A, sewer construction starts from the starting end and then progresses towards the outfall. Option B, sewer alignments are carried out in straight lines between manholes. Option C is dewatering trenches are required for the placement of concrete bedding and laying of pipe sewers and or construction of concrete and or brick sewer till curing. Option D is horizontal sewer layouts determine hydraulic carrying capacities. Big options. I'll give you a couple of minutes. Which one are the incorrect statements? Which ones are the incorrect statements on sewer layouts or installations? That you have to think. Okay, you have given the answer as A and B. A is indeed a incorrect option. Now, sewer alignments are carried out in straight lines between manholes. Between two manholes, sewers will be in straight line. It's a correct option. Okay. Whereas horizontal sewer layouts don't determine hydraulic carrying capacity. So it is one incorrect option. So A, you have identified it correctly. It is an incorrect, but instead of B, it will be D. Okay, just memory based question. You have to remember if you from SARS lectures. Now the next you have given a picture. Based on it, the MCQ is as follows. Which sewage system is depicted in the figure? That you have to identify. Do you need options for this? Okay, so option A is combined system, option B is separate system, option C partially separate system, and option D is none of the above. Okay, so you're telling C may be the answer. We'll see. So the answer is option A. It is a combined system. You can say there are rainwater inlets also, there are manholes also. So electricity supply is also there. Okay, so that's why due to the presence of all of it, it is a combined system. There is no separation, neither partially nor full. Now we'll move on to our next MCQ. You have to choose the incorrect statement regarding the hydraulic routing of storm water from the following options. Option A is kinematic wave is the basic hydraulic equation that includes gravitational and frictional forces balancing each other. Option B is diffusion wave routing equation incorporates pressure forces only. Option C is dynamic wave equation considers all terms of momentum equation, and option D is inertial and pressure forces negligibly affect kinematic wave motion. Regarding the hydraulic routing of storm water, three options will be correct, one option will be incorrect. So incorrect option you have to identify. Okay, you are telling D as the answer. We'll see. So incorrect statement is B. Diffusion wave routing equation does not incorporate pressure forces only. All of the other options are correct, including option D. Why we will see that. So the diffusion wave routing equation incorporates gravitational and frictional forces in addition to pressure technology. So that's why option B is incorrect. Internal and pressure forces does do negligibly affect the kinetic wave motion. So that's why D is the correct option. B is incorrect. Okay. Now next MCQ is the discharge point of the treated and or untreated sewage is called as option A invert level, option B night soil, option C outfall, and option D decomposed sewage. Okay, you're telling us B as the answer. Night soil. I hope it is correct. Let's see. So I don't think now. The explanation is outfall is the discharge point of the treated and or untreated sewage. So option C, outfall is the answer. It is the discharge point of the treated and or untreated sewage. Night soil is something when there was time that there was not proper sanitation system in villages and all. So there was a collection pot at the bottom of the sanitary latrines. So there the fishes fall, and at the next morning, the people who are in the trade of that they actually used to collect those things. This is called as the night soil. It is not a discharge point. So discharge point is called the outfall of the treated and not untreated sewage. Okay. Now next one is another an MCQ. Excess groundwater recharge results in option A water scarcity, option B watershed development, option C water logging, and option C D is surface runoff. Okay, so yeah, also try again this one. Okay, you are telling no, you are not yet able to answer this. Mm, okay, we'll see. Should we wait for a couple of more minutes or okay? So let's proceed with the answer. So now, yeah, water logging is the answer. Excess groundwater recharge results in water logging. Water scarcity is not cannot occur. Water scarcity is due to the lack of water. So excess groundwater recharge will not cause water logging. Watershed development is a surface phenomenon. It will not cause inside the ground. And surface runoff is something. Uh, it is not excess groundwater recharge. It occurs because of the rainfall. Okay. So option C is the correct answer. Now next. MCQ is, which one of the below is considered while choosing location of the sewage treatment plants or STPs? Option A, treatment process. Option B, earthquake records. Option C, quantity of sewage. And option D is the runoff rate. Okay, we are telling option C as the answer. So the answer is location of the STPs, contour, elevations, and or soil tests are conducted at first. Rainfall data for 50 years and or highest intensity of rainfall, earthquake records, maximum flood level at site, and or in the receiving water windrows. These are the factors. So option B, earthquake records is the answer. Option C, quantity of sewage is not. Okay. Quantity of sewage is something definitely related with the design of the sewage treatment plants. But while the matter comes into the choosing of the location of STPs, then earthquake records becomes important. Okay, treatment processes, quantity of sewage, runoff rate, these all are design aspects. But earthquake records is something related with the choice of location of the STP or sewage treatment plant. Next MCQ is, which one among the below does not relate to the need for artificial recharge? Option A, rainwater harvesting. Option B, groundwater depletion. Option C, seawater intrusion. And option D is geogenic contamination. Which one among the below does not relate to the need for artificial recharge? Artificial recharge is not related to which one of the four options? So three options will be related to the artificial recharge, right? Okay, you're telling option A as the answer. So yeah, rainwater harvesting. This one is correct. Rainwater harvesting is something that doesn't relate to the artificial recharge. All of the other three things like groundwater depletion will require groundwater recharge, artificial groundwater recharge by human intervention, then seawater intrusion, geogenic contamination, all of them require artificial recharge, whereas rainwater harvesting does not relate to the need for artificial recharge. Now next, there is multiple select question. Which of the following statements is or are false with regards to STPs or sewage treatment plants? First option is construction cost decreases by integrating multiple sewage processing units. Second option is circular tanks can be placed side by side. Third option is construction cost increases by integrating multiple processing units. And last option is rectangular tanks can be placed side by side. So whether circular tanks or rectangular tanks, what can be placed side by side, that you have to determine, and whether construction cost increases or decreases by integrating multiple sewage processing units, that you have to determine. So either option Q or S will be correct, or between option P and R, one option will be correct. That's all. Two options, I believe, in this question should be correct. So other two will be the false, that you have to determine with regards to sewage treatment plants. Q and R. Okay. So the answer is basically your false. Okay. False statement you have to determine. Q and R are indeed false statements. So rectangular tanks can be placed side by side and construction cost decreases by integrating multiple processing units. So P and S are correct options. Q and R are false. Okay. Yeah. You have determined it correctly. Now next is column matching. So how do you have to match the factors? Those are provided in the left hand column, considered while planning for artificial recharge with their right hand column description. So factors are climates, topographics, and hydrogeologic conditions. And the descriptions are uh, the factor determines the extent of runoff and retentions. Option 2 is determine the occurrences of potential aquifer systems, and number 3, third description is the factor determine the spatial and temporal water availability for recharge. So which factor goes with which description? You can keep PQR as same, and you can tell me the correct order of 1, 2, 3. Okay, so R goes with 3, then Q with 1 and P with 2, that you are telling. We'll see. So the correct description is 3, 1 and 2. You are telling no, so R goes with 2, not 3. Q with 1 and P with, okay. So Q you have identified it correctly. R to Q3 P1. Yeah. So no, it is again wrong. So previously you identified Q correctly. Okay. Secondly, you identified R correctly, but again P got messed up. Okay, so we'll see. The climates determine spatial and temporal variation of water availability for recharge. Topographies determine the extent of runoffs and retentions, and hydrogeologic conditions determine the occurrences of potential aquifer systems. So PQR with 312, this is the correct options. Okay, it's okay. Just you. This is also again a memory-based question. So if you have watched the lectures, you can identify them correctly. Otherwise, you have to revise. That's all, before the final exam. Okay. So the next is MCQ or multiple choice question. In the self-purification method of sewage treatment, which one of the following takes place in the recovery zone? Option A, active decomposition. Option B, anaerobic decomposition. Option C, stabilization of organic matter. And option D is decomposition of solid matter. Okay. So one option will be correct. Self-purification method of sewage treatment in the recovery zone. Which one of the following four options is true with respect to that? Yeah, it's okay if you are not able to answer all of them correctly. Participation is highly encouraged. You are trying those things that I mean that only sets your standard with respect to the other candidates, because those of you who will be watching this recording later, that is who will be watching the recording at a later stage, that is also fine. But for them who will not be watching or who will not be practicing, uh, I mean, getting good marks or passing in the final exam will be difficult for them with respect to those who are practicing in the sessions. So yeah, you have given the answer as B, anaerobic decomposition. Okay, so we'll see. So the answer is stabilization of organic matter takes place and BOD reduces in the recovery zone. Also, bacteria decrease as the food supply decreases. So we have already clarified the concept of BOD, which is biochemical or biological oxygen demand, in one of our previous classes. We have also solved a problem based on the BOD in order to further clarify your concept. So I thought it would be helpful for you. So option C, stabilization of organic matter, is the correct option in this case. Okay, B is not. Anaerobic decomposition is not, because BOD is something related with active decomposition or your decomposition in presence of oxygen. Okay, so it cannot be anaerobic. If oxygen is present, that means air is definitely getting mixed. with the water, uh, with its splashing and all. So that's why option C is correct answer. Now, next MCQ is, which one of the following retains groundwater for longer periods of time in the basin and or watershed by arresting the subsurface flow? Option A, aquifer well. Option B, shafts. Option C, surface basin. And option D, bandhara. Which one of them retains groundwater for longer period of time in basin and watershed by arresting subsurface flow? Subsurface flow is flow that is happening underground. Now, one of these structures basically restricts that flow, and in this way, it can retain the groundwater for longer period of time in basin or watershed. For a couple of minutes. Okay, you are telling option D as the answer. We'll see. So the answer is option D, Bandharas. Correct. Now, what is Bandharas? It's basically looks something like this. It is a specially crafted dam, nothing else. Okay, this one particular Bandhara is from Maharashtra. Yeah. Now, the next MCQ is, which one of the following phenomena happens when soil pores continuously decrease and the soil gets clogged by deposition of solids? Option A, sewage sickness. Option B, sewage farming. Option C, flooding. And option D, surface sewage logging. One option will be correct. Which one of the following phenomena happens when soil pores continuously decrease and the soil gets clogged by deposition of solids? This phenomena is termed as sewage sickness, sewage farming, flooding, or surface sewage logging. Again, you are telling option D as the answer, right? Surface sewage logging, you are telling, but it is sewage sickness. Again, it's a memory based question. The definition of sewage sickness is something like this that you have to remember. Okay, it is not surface sewage logging. because it is inside, right? It is not happening at the surface level. Soil pores is getting decreased at the inside of the soil, and the soil is getting clogged. There is no clog that is being observed on the surface, like in the trenches or in the canals or any other waterways, like lumens and all. There, the clogging is not being observed. The clogging is happening at inside of the soil because of the decretion of soil pore and the deposition of the soil, the deposition of the solids. So that's why it is called as sewage sickness. Now, next is you have to match the following illustrations with their respective research techniques and choose the correct sets from the options. Okay, so the options are as follows. Where is it? Where is not coming? Yeah. So the illustrations are given like this way. So these are these three illustrations or three pictures, and the options are trench, aquifer well, and excavated basin. You just take a notepad and write these three options there. Trench, right? Trench, aquifer well, and excavated basin. That you just note down these three options. Okay. One is trench, another one is aquifer well, another one is excavated basin. Now next, I just have numbered the illustrations as 1, 2, 3. You have to tell which one is trench, which one is aquifer well, and which one is excavated basin. AW aquifer well and EB for excavated basin. One, this, two, this, three, this. In this way you can write. So one is trench, another one is EB, another one is AW. Okay. So this one I have numbered at 1. This one I have numbered as 2. This one I have numbered as 3. So one is trench, another one is aquifer well, another one is excavated basin. And these are their numbers. I'll wait for a couple of minutes. Not able to answer? Should we proceed? Trench, it is in local terminologies, it is called as porikha. It was drawn when kings wanted to uh, protect their forts from enemy attack. If you have seen one uh, movie, it was a very popular movie, Jack the Giant Slayer or something. The movie name was like that way. There you might have seen these kind of trenches. So you should be able to answer which one is trench. Which one of them is trench? Basically. One is excavated basin, two is trench, three is aquifer well. I don't think so. I think option three is the trench. Okay. Trench is something in cross section, it looks like this. Number one is aquifer well. It is not excavated basin. Okay. So this one is the excavated basin. It is very common to confuse between the aquifer well and excavated basin, which looks almost similar. But you can see the idea is, in case of aquifer, you are trying to extract the water from the soil. So that's why within your excavation there are pores, you can see. Through these pores, the water from the soil will come and rise through this aquifer well. But in excavated basin, subsoil pores are not there at the surface of your excavation, because here the idea is not to collect the aquifer in the way collect the water in the way aquifer oil does. Okay, so that's why option 2 is called the excavated basin. Now option 3, I wanted you to be answered this one correctly. So option 3 is the excavated, the trench. Okay, nevertheless, no issue. So today's last question is, you have to you have to match the following left hand column figures with the given right hand columns techniques, sewage farming techniques, and choose the correct options. So again, three different figures are given to you, and the options are: number one is subsoil irrigation, number two ridge and furrow, and number three is flooding. Okay, so what you can do, you can just keep the left hand order same and tell me the correct order of the right hand side. So it is 1 2 3. You can tell me the correct order after rearranging. This one is the last question of today's session. Just tell me the correct order. So right hand side is 1 2 3. Whether it will be remain as it is or it will change. The order will change. That's only you to tell. Keeping the left hand order of the pictures as the same. Thanks for active participation in today's class. So only one session is left. If you are having any doubt, you can ask the next session, or in this session itself, or you can raise it into the discussion forum. One of the students I saw has raised one question in the discussion forum as what is the what are the type of questions that will be asked in the final exam. So I will suggest all of the different types of questions that are discussed till this session and also will be discussed in the last session. I'll suggest that student and also to the other students, whoever having this question, I'll suggest all of them, uh, sorry about that, I'll suggest all of them to study all of the uh, different types of questions that are discussed in different types of sessions. In all these 12 sessions, we'll ask them to either watch the recording or go through the slides. Okay. So this is the last question. So we'll see the correct answer. So the second one, this one is called as number one. This is subsoil irrigation. The third one, this is your ridge and furrow, and the first one is called flooding. So 312 is the correct option. We have told as 231. So yeah, three. Okay. So this is the correct option. Yeah, 231 is not the. Okay, okay. You told first one is the subsoil. Second one is the yeah, yeah, yeah. Correct, correct. Ridge, ridge and furrow and flooding number. Yeah, yeah. 321 is the correct order, but yeah, you have identified it correctly. So the first one is the flooding. The second one is the subsoil irrigation, and third one is ridge and furrow. Yeah, this question you have identified it correctly. Okay, so thank you. With this, we end this session. If you have any doubt, you can ask. Otherwise, we'll end. Okay, so good night. We'll meet you in the next session. I will stop the